Hello. In this video, we're going to take a look at lists as our first mutable data structure. That is, we can change them. We're going to look at assignment, copy, and actually how these are implemented with namespaces because that helps explain how some of this works. And then finally at the end we'll take a look at deep copy. So I'm starting out in the shell. We have L1 as a list. It has 3 strings in it, car, dog, and a silly string called XYZ. And so to help explain what's going on here, we'll have a picture of our namespace, and in that namespace we show our name, L1, and the list with car, dog, and XYZ in it. So the first thing we're going to do is what happens when I say L2 equals L1. Well, in our picture, we see that L2 is another name for the same list. So in this way, now if I change L1, pretty clearly from the picture, we'll see that L2 will also change. So, for example, let's take the element 2. Remember, we start counting at 0, so that would be the XYZ. So let's take element 2 and let's have it equal the string tree. Obviously L1 changes, but note that L2 also changes. So in our picture, what that means is we've taken the XYZ and changed it to tree. Since L1 and L2 are two names for the same list, when we change an item in L1, we see the change also in L2. Let's make a new list, L3. And L3 is, well, let's put some numbers in it, 1, 2, 3, and L1. Let's put a list in there. Now, how does this look in our picture? Well, 1, 2, 3, L1. L1 now refers back to the original list. So if I take a look, what does L3 look like? It looks like the numbers 1, 2, 3, and the list L1, car, dog, and tree. Now what happens if I take L1 or even L2, let's do L2 this time. L2, let's take the item 1, which of course is our second item because it starts at 0. That of course is dog, and let's change dog, the string dog, to the string cat. Now, what has happened? Well, if we look in our picture, we see that we've changed the string dog to cat. So of course, if I print out L2, we see we get car, cat, and tree. And of course, L1, since there are two different names of the same list, we also get car, cat, and tree. But notice what happened with L3. That also reflects the change. From the picture, because it's 1, 2, 3, and list 1, whatever we do to list 1 shows up in list 3. Now, suppose we wanted to create a list where a copy of a list where making a change didn't show up in the new list. So let's make L4 equal to L1 and make a copy of the list. So we can use slicing, which makes a copy of the list. So we've made a copy of L1 and named it L4. But notice the difference in terms of the diagram. Rather than L4 referencing the same list, we have a copy of the new list. So what has happened on the right-hand side of the equation, L1 with the slice colon there, that actually makes a copy and assigns it to L4. So now if I go back to my original list, let's take L1, let's change the first element from car to fox. And we see that L1 has changed. We see that L2 has changed. In fact, of course, L3 has changed, but L4 has not changed because it is a copy. Again, if you think about how it shows up in the namespace diagram, that shouldn't be surprising. Now, let's make an L5, and let's see what happens when we make an exact copy of L3 this time. Of course, L5 looks just like L3, but what has happened in the diagram? Well, my L5, because it's a copy of the list, it's a copy of 1, 2, 3, and L1, so it still refers to L1, and any changes that I make in L1 will, of course, show up in L5. So the colon is called, when we make that, that's called a shallow copy. If I want a separate copy, I have to do what's known as a deep copy. And in order to do that, I need to import copy. And let's make an L6, which is a deep copy. So that's copy dot, if I want to see the possibilities, there's deep copy. And we see that it takes a reference. So let's make a copy of L3. We'll make a deep copy of L3. And in our diagram, what's happened here is L6 now is an entire separate copy. It has no reference to L1, so any changes to L1 won't be reflected in L6. And we can see that. Let's take L1, 2, and let's make that equal to elk. And in my diagram, we have yet another change there. So if I look at L1, we see it has elk in it. If I look at L3, we see it has elk in it. Of course, L5 will also have elk in it, but L6, which is a separate copy that has no reference to L1, it now has, it shows no changes. So what we've looked at here is how assignment works. It gives two different names to the same list. We looked at how a list within a list was specified, and that references the original list, so copies of that list also reflect changes. We saw how to make a shallow copy with a colon. Works fine, giving us a new list, unless it's a list of a list, in which case if we want a totally new copy, we have to make a deep copy of that. That's enough for this time.